so I'm really excited about being here because this is basically our user community for problem testing purposes. So I did want to cover just some of the features that are going to appear in future versions. Hopefully all this stuff will be available for Kermit. We'll see. PCI pass-through. This allows you to pass through a physical PCI device to a guest. For instance, let's say you had an extra network card and you had a Windows guest that you really wanted to perform well. You could have direct access to that PCI card in the Windows guest. There are other reasons why this is interesting other than that. If you're a kernel developer and you want to do development of a hardware driver, you can actually do your development in the guest and have safe access to that device within the guest so that, if your driver's buggy and crashy, it's not going to take down your host environment. That's actually a really useful part of this. SRIOV is related to PCI pass-through. Modern network cards and some other devices, but right now mostly network cards, actually have the ability to self-virtualize themselves. So a single E1000 will show up as, I think, 32 PCI functions. And the idea is that you could then pass each of those functions directly to the guest. You need the right hardware to do this. You need a pretty modern Intel motherboard, but it'll become more common. Another interesting area, and this is still very, very new, so I don't know if it'll be around in the Karmic time frame, is Red Hat acquired Kubernetes, who were the original developers of KVM. They had developed a VDI infrastructure based on a new remote desktop protocol that they call SPICE. And all of that infrastructure is currently being, or at least these parts of the infrastructure are being reorganized to be released as open source. And hopefully we'll be able to pull out a lot of that in. What this practically means is that there's a lot of enterprises that are interested in virtualization specifically to run Windows desktops, or even Ubuntu desktops. That's also a popular thing. And if you're familiar with VNC, it's not the greatest protocol in the world to do remote desktop access over a slow link, or even a relatively fast link. And QXL and SPICE address some of those concerns. Next slide. So this is the part that I get really excited about, mainly because I don't get to do that much development anymore. So I get excited about silly things like release processes. So KVM is kind of a curious project. You may have noticed that we have, our current version is something like KVM 86. And the reason for that is that in 2.5 years, we've had 86 releases. That comes out to about a release every 2 to 3 weeks, sometimes 4 if it's a particularly difficult release. This has created problems because, so this is a graph. I couldn't figure out the best way to do this in OpenOffice, so I ended up doing a scatter graph. But these are all of the releases over time with a number of change sets. And you'll see that it's relatively, except for a few outliers, this is a relatively stable development process, and the releases are more or less just development snapshots. So the folks here who have been shipping KVM versions have basically been taking development snapshots of the Git tree. And that's totally our fault because we haven't been providing, real releases. So this is something that we've come to realize is not going to work out for the long term. So you go to the slide. So we now have a proper release process. It's driven by QEMU, so the KVM bits are in the kernel, so it follows the kernel release process. The new QEMU release model, we're doing every 6-month releases. This is largely inspired by the fact that there are a bunch of other projects, like Ubuntu, that have had real good success with time-based releases. And 6 months works out because a lot of projects use 6 months, including Ubuntu. One of the things that's the most exciting for me, and I know I've mentioned it a few times already to some people, is that we have a proactive stable tree now. So every patch that comes into me or any of the other maintainers, we consider whether it's a bug fix. And if it's a bug fix, we backport it to the stable tree. So our stable tree has been around now for a few months, and it's acquired a lot of bug fixes, like on the order of, I think, 150. So I think there's an interesting discussion about, how does a distro keep up with something like that? Because I don't know that you would want to include 150 patches as updates. But one of the real reasons we're doing this is that we want to have that stable stream that people can pull and package, and we don't have to worry about all sorts of regressions. Because one of the problems is, like, if you take something like Hardy, I think Hardy was 72 or 74. 62, sorry. But so 62 really has no significance to the upstream KVM community. It was just, it happened to be what the version was at the time that Soren made the package, and we're not really interested in fixing bugs in KVM 62, which creates a bad situation because then you're kind of on the hook for fixing all those bugs yourself. But now in Karmik, and I think that's on the next slide, we'll be on one of these stable releases, and then we'll actually be interested in the bugs again. So hopefully everybody's lives will be better. The other bit is that we haven't gotten to the point where we have an old stable tree yet, but when we do, we're going to be looking for volunteers to maintain that tree. So the best people to maintain stable release trees are those that are shipping them in products. So that would be something to consider. Okay, so I wanted to include a slide too to talk about some of the things that we can work together better on. I actually think that so far we've been doing a pretty good job of working together. The stable release, I think, is the key point, because I think having a stable release is going to be the best way that we can have a high-quality KVM package for Ubuntu, and that upstream can help support and do bug resolution on. I'll always be interested in stable release bugs, so I'll never turn them away. One of the biggest problems we had with the KVM packages, other than the stable stuff, and I'm sure this is something that's shared with other projects, so I think it's appropriate to bring up here, was that the packages carried a lot of patches that never made their way into the upstream tree. In all fairness, this wasn't all Ubuntu. In fact, the majority of it actually came from Debian. For a while, the QEMU packages and the KVM packages were coming from Debian, or at least were based on Debian at some point, and they were carrying a bunch of patches. And it's one of those things that if we rejected a patch in upstream, and then we get a bug report from a user or even from one of the package maintainers, and that patch is in that package, even if it's unrelated, it's kind of almost insulting to us, and it's going to make us not want to look at the bug report, right? There's always a reason that upstream rejects a patch. Now, in the case of QEMU, it's not entirely, Debian and Ubuntu's fault. Some of it was that we weren't as responsive to patches as we should have been. But that's an issue that we should fix together, right? Like if there's a reason that you're unhappy, you think we're not taking patches that we should be taking, the right way to fix that is to have that dialogue and to fix that problem instead of just carrying patches that we haven't included for one reason or another. That said, Dustin and I sat down a few times actually, and now the packages are wonderful. The Ubuntu packages aren't carrying any patches that aren't upstream except for things that are related to configuration and packaging stuff. So I'm really happy with the current packages. And that's it. So any questions or comments?
Two. Does KVM enable us to adapt power virtualization for machines lacking in virtualization?
No.
Is there any interest on KVM either on the power or IKV architecture?
Okay, so just to elaborate more on your first question. The question was, will KVM ever support hardware that doesn't support hardware virtualization on x86? And the answer to that is no. And the reason is, it's as from a development perspective, it's kind of a lost cause for us because as time goes on, every processor will have hardware virtualization support. So it doesn't seem like it's worth the effort to invest in code that is going to be obsoleted in a short period of time. And you lose more users every day as new hardware comes out. The second question was power and Itanium. KVM supports Itanium today. KVM supports power for embedded power PC, not for server power PC. There is somebody who's trying to get it working on 970, which would be the thing that I think most people would have access to. So that is there today. There's also S390 support for KVM, which is pretty fun. It turns out that the hardware virtualization support in Intel and AMD is very similar to okay. It's very similar to that on the mainframes. So S390 KVM made a lot of sense, which I think surprised a lot of people. So.
What steps do you take with your stable trees to guard against regression sneaking in, and do you encounter regressions before they have into a tree?
So far we've carried about 150 patches, and we've had one regression, and that regression was because I backwarded the patching row. It's testing. I don't get to write code anymore because I spend all my time building testing infrastructure and reviewing patches. So that's one of the major focuses of the KVM development effort right now is building better testing infrastructure.
You plan OpenGL?
I think the question was, do we plan OpenGL pass-through?
Yeah.
There are some things that allow OpenGL pass-through today. I forget what the project is called. The general problem with 3D virtualization pass-through is that you can't make it work reliably without hardware support. There will always be limitations without hardware support. And newer hardware, like NVIDIA, has recently announced the ability to do 3D virtualization. So as that hardware becomes more common, we'll then support that kind of virtualization.
Second question, hard port. And second question, how long is a long time?
Oh, yeah, okay. So ARM port, we don't know why there isn't one already. Every year at our KVM forum, Avi makes predictions about what's going to happen in the next year. Each year, ARM port's been one of the predictions, and it hasn't happened yet. I don't know why. How long is a long time? Probably years. Because it's easy to maintain the stable trees. Sorry, that was the last question, but you can ask me afterwards if you'd like. Thank you.
Hi, thanks for having me. I owe those who made that happen. It's great to be here. I've been with you here. Next slide. Just a few quick slides of who I am and why I'm here. This is about R, which is about programming with data. I work with data all day and analyze and try to write predictive models. But as in grad school, I've also maintained packages for Debian, in particular the R stack, and then upstream also for public. And there are a couple of other things I do around the R context, in particular, sort of making programming more visible or easier to use. All of those. I may come back to this very often in a moment. There's something that I said is a project from last year somewhere. The data, stupid. We're all IT people, we're all programmers or user interface designers. It's all about code. Code, at the end of the day, is about moving bits around, and bits really is data. And with this talk, and with the focus on R in general, I want us to refocus back on data, because we do this at the end of the day to process information, to make better decisions. So this was something that came up from Hal Varian. Part of my training, part of it was also economics, and he's a relatively famous microeconomist and information economist. He's now on leave from Berkeley and is Google's chief economist. And he made that prediction that the data revolution is just about to get started and get going. It's the same reason why O'Reilly has this very good short slogan about data inside. I mean, it's really about what we do with the data. And I think this ties in wonderfully with what we're seeing now with computers and open source. Hardware is getting cheap and to be everywhere, and so is data. But the data alone doesn't get you anywhere. What you really need to do is do analysis on it that's better. I just want to bring two examples in about how it's actually getting a lot worse with data, because you always think, well, what do I care? I mean, Moore's law is going to bail me out. No, it's not. I apologize for the chart. Most of the talk, a bit of it is recycling from something where I talked before this year, but most of it I actually wrote while I was here. The timeline is from October 06 to October 08. The axis has, I believe that was 200,000 a year, and it's a million there. And this is the number of rates in a feed called OPRA, which is for options pricing, which covers equity, the underlying stocks as well as the exchange listed options. And this is the number of quotes and trades that come in every second. My day job is in finance, so people worry a lot about low latency and high throughput, but I, as a data analyst, actually get to work through these mountains of data. So you need better tools, and you need to have your tools scale with the amount of data that comes in. Another example, which we use in the motivation of the VC survey paper I was part of for parallel computing with R, was that for the DNA sequencing people in bioinformatics, they used to say that a data set can't really fit on a CD-ROM. Now they have faster sequencing mechanisms to analyze DNA sequences, and within minutes, these things emit data sets that no longer fit on a DVD. So there's a real need for faster, better computing. Which brings us to R.